Hello, everyone. My name is Susan Kudalakis, and I'm Senior Marketing Manager here at Progress. Welcome to our modern ABL development for today's OpenEdge Applications webinar. Let's start by quickly introducing you to your speakers for today. I am joined by a panel of speakers led by Tony Prettyman. Tony Prettyman is Senior Director of Product Management at Progress with 27 years of hands-on OpenEdge experience where he leads product strategy and vision for OpenEdge. He partners closely with engineering, sales, marketing, and customer success teams to deliver solutions that enable organizations to modernize mission-critical applications and drive long-term business value. Roland DePiper is Senior Principal Consultant. Some say he naturally faces magnetic north and that wherever you are in the world, if you turn your radio to 88.4, you can actually hear his thoughts. All we know is that he joined Progress in 1995 and has ever since been helping customers make the best use of the latest Progress technologies. With over 20 years experience, Cameron brings a unique perspective to OpenEdge users, having worked on both the consulting and engineering side. He excels at listening and helping OpenEdge customers and partners find solutions to complex problems. With a keen eye for looking at code and systems, Cameron has played a pivotal role in helping customers migrate to the latest versions of OpenEdge. Steve Southwell is Principal Consultant with Progress, bringing nearly 30 years of experience in software and development and consulting. His work is focused on designing and supporting secure, high-performance transactional systems with a particular emphasis on reliability, maintainability, and security. Edsel Garcia is software architect in the Progress OpenEdge engineering team with more than 30 years of hands-on experience with Progress products, starting as a customer and application developer. While at Progress, he has contributed across multiple teams and initiatives, including Pazoe Docker containers, OpenEdge CI/CD and high availability, and the OpenEdge memory profiler and MCP server. I'm really excited to have all of our speakers with us today, and now I'll turn it over to Tony to start the discussion.
So, welcome to this part of the webinar, so my part of the webinar. And I'm going to tell you a little bit about AI assistant development in combination with the advanced business language, or ABL, and how this all fits in with a modern IDE. Maybe to start off first with the challenge that we had. So last year, we've been assigned with a task by John Ainsworth and said, well, we need to do something for the ABL developers to get AI development into their system so that they can make better use of artificial intelligence. The challenge that we had at that moment was that most of those LLMs out there, they've all been trained on coding, they've been trained on many different languages, but not on ABL. That has nothing to do with ABL itself. It's just that there are a lot of open source repositories out there for Java, C#, what have you, but just not for ABL. We have several of our customers. We said, well, we have a huge ERP system. Can you make your code public so that we can train ABL, that we can train LLMs on it? Well, we didn't get any volunteers, as you might understand. So that was the biggest challenge. The LLMs, they know coding, but they just don't know how to generate perfectly good ABL code. And just as a proof point, when I go to the web and I just go to ChatGPT or Gemini or whatever, and I ask, well, generate me a hash map collection for employees. It will try to do that, but as probably you all see here, this will not compile because our hash map just requires parameters of class types. So it requires objects and not simple types like integer and character. And if you're using Gen AI, you want the code to be generated that it should compile. You know, that should be the least of your worries. If it's functionally correct, well, that's maybe up to your prompting, but it should compile. It should be perfect ABL code. So the solution we came up with, and I'm going to describe to you a couple of the steps that are involved, how to get there. The first one is the integration that we created. The AI assistant is based on VS Code. VS Code is very open, and all the AI stuff that's been happening over the last so many months and years is all happening in Visual Studio Code. Luckily, there is now a plugin for it, the Riverside plugin, so that you can use it for your ABL, for your development, for debugging, for running your code, and so on. To be able to use our solution is a cloud-based offering, so we have an MCP server running on the Progress Data Cloud. It's called the OpenEdge AI Assistant. Your IDE, so the VS Code that you're using, it could be plain VS Code with a plugin. It could be one of the forks that have been developed, like Cursor and Windsurf and Gravity. They all should be able to connect to that MCP server And to facilitate that, we have created a plugin. So that's this OpenEdge AI Assistant. You can just find it on the VS Code marketplace, or if you're using a VS Code fork, you can find it on the alternative marketplace, the OpenVSAX marketplace. So just search for OpenEdge AI, and then you will find this plugin. As it says here, it supports most of the IDEs that are out there. And what it will do, if you install it, it will automatically update your configuration. So it will update your MCP configuration file per IDE that can be located in a different place. You know, it can be in your workspace, it can be on a global level. It could be, in most cases, it's a JSON file, but it could also be a YAML file for some of those IDEs. That will be taken care of automatically. And what it will also do is it will take care of the refresh of a bearer token. So for security reasons, we use a bearer token that has to be refreshed every hour. The plugin will take care of it, so you don't have to worry about it anymore. Once you've installed the plugin and your configuration is up and running, we supply at this moment 3 different ABL versions, which means that your IDE or AI, if it needs to know something about ABL, it will ask the AI assistant, and that needs to be pre-configured. You need to set a rule that says, well, I'm on this OpenEdge version. It could be 12.2, 12.8, or the latest innovation release, 13.0 in this case. So by just adding a rule to it, your AI will know which syntax to pick. Because if you're on 12.2 and you want to generate code using a hash map collection, that's not going to compile. Although it will generate perfectly fine code, but it will not compile in your environment. We added the latest collection to it because being on an innovation release means that in the next innovation releases, you would not have to change your configuration. It will always pick the latest ABL syntax in the latest innovation release without you making any changes locally. And once you've done that, you can start chatting with the AI using the plugin that will also understand the database configuration, like having your database schema in there, so it knows how the table relations are in your application. And it will, based on that, it will recognize the ABL syntax and start generating code for you. One of the things that you will probably miss if you're migrating from Developer Studio, so the Eclipse-based environment, to VS Code is that VS Code does not have all the wizards that we have in Developer Studio, like new class, new procedure, new what have you. In an AI world, this can be done much simpler than before. So in Eclipse-based applications, you had to implement your own Java code for this. There's a jet engine behind it, and that was pretty complex. With an AI environment, the only thing that you basically need to do is you just need to type whatever you would like the AI to do at inference. So in this case, there's a markdown file. Basically, all the AI stuff is based on markdown files. And this just describes what needs to be done if you want to create a new class. So it's not a complex pattern behind it. It's not templating. It's just describing, okay, if I want to create a new class, then at least I need to have the class name and I need to have the package where the class will be situated. Do I need to inherit from a certain class, interfaces to be implemented, and so on. Of course, this part of the code, I did not write it myself. I asked the AI to generate it. But this just means that every time again later on, when I want to create a new class or a new method or a new procedure, I just execute or ask the AI to execute this markdown file, interpret this, and it will be automatically running all those different steps for you. And that makes life a lot easier. And in fact, also your homegrown wizards that you already created before, it's very easy to port them because you just tell the AI what the wizard should do. Once you have this all up and running, you can really start making use of the AI. As an example here, for modernization, like maybe you want to migrate parts of your current business logic, which is still in the user interface. You might want to migrate it to the app server, replacing parts of a GUI application with web interfaces. by just making sure that you have the right markdown files, the right rules, the right skills. It's pretty straightforward to start implementing those. And as you can see here in this example, even with a ticket, like with a Jira ticket or a GitHub issue, you can, if you make your requirements clear enough, you can point the AI in the right direction and it will pick up those tasks for you. Of course, if you start generating code, you want the code to be consistent with what you already have. You have your own coding standards, your guidelines, naming conventions, what have you in your organization. So the code that's being generated should be compliant. And again, this is now a lot easier because you can also do this in Markdown files. So by just describing the rules, and especially coming up with examples, like what you can see here for non-serialized error classes, you can describe it like, okay, this is how it should look like. This is a good example. This is a bad example, and that's especially good for AI because, yeah, that's where it learns from. Having the good examples, that really works. Altogether, describing these kind of rules that I mentioned before, that helps you to define the standards for the AI to generate code. Now, you will find that if you start collecting all that information, that will become quite a large markdown file. There will be a lot of stuff that you've defined over the years about your way of working, your guidelines. If you do that, then that will grow over time, and that will all eat up context, because that means that every time when you go out to the AI, when you go out to an LLM, there will be context added to it. And the larger the context, the lower the quality of the AI, of the generated code, because the AI will just become confused. There's too much context that it needs to keep in mind. This is an example of a skill file. So by dividing those kind of rules in smaller parts, so more fine-grained rules, basically, those are called agent skills, which make sure that at inference, the AI will only use the rules which are really relevant for that specific task. And that speeds up the process and makes the outcome much more reliable. So adding that all up, asking the same question, but then with the correct level of rules in place, but also using our AI assistant. Once I ask this one to generate the same hash map collection for me, it will know, okay, then I need to use the OpenEdge.core.string for the first part of the input. So wrapping it all up, using the AI assistant will generate me the correct ABL syntax that I was looking for. So in this case, it generates a hash map that expects an OpenEdge.core.string as first parameter and a progress-lang object as a second parameter. So this ends my part of the webinar. Over to Tony.
Thanks, Roland. So now we know how to write modern ABL code with the right tools. But before you start building, you need to think about how your application is going to perform at scale. Getting the architecture and query design right up front saves you enormous headaches down the road. Cameron, from our A team, you see this firsthand in your Project Garage engagements. What should developers be thinking about when they're designing for scale?
Thanks, Tony, very much. Yeah, you have to take into consideration horizontal scaling. What is exactly horizontal scaling? And really, why does it matter? We've spent a lot of time and resources building out our PaaS server, which, as many of you know, runs on top of Tomcat. Tomcat is an industry-leading web server that gives us that ability to horizontally scale. Modern applications have increased demand, and with adding AI on top of that and adding MCP servers, and the demand for knowledge and information only expands on this requirement. There's, as I say, an increased user demand. Availability has to be available all the time. If you're not available, your customers are going to go somewhere else, and that's where we get this zero or low downtime expectations altogether. Some of the things that horizontal scaling will give us is that elastic growth, that fault tolerance. You have a PaaS server go down, PaaS servers go down, we write bad code, PaaS servers crash. With that horizontal scaling, there's always a warm spare up and running, and your customers never get to see the difference. It also allows us to do things like blue-green deployment, which you're going to hear about later on in the presentation. The simple definition is horizontal scaling adds more PaaS instances instead of making one server bigger. So what is horizontal scaling in PaaS? Well, it's running multiple PaaS instances. You run them in multiple virtual machines. You can containerize. We do publish a PaaS container, a PaaS Docker container. You can load that into Kubernetes or Swarm. Or you can just physically run or it's not old, but you can run physical machines. The key concept here is instead of one big PaaS machine running all of your different applications is to run many smaller ones. You've heard in the Docker world, they talk about VMs as cattle, not pets. We don't love them, we just make more, right? What are the key benefits? You definitely have improved throughput. Availability is increased. You can definitely isolate faults, and it's much easier for upgrades and deploys. So the first key to that is load balancing. Well, how do we do load balancing? Because the load balancer is really your endpoint where everybody comes in. It distributes the income load in different strategies, and there are many different strategies out there. Which ones are the best? Well, I'm going to obviously say Progress Kemp Loadmaster is our best, but you've seen different ones, Nginx, F5. Pick a load balancer that works for you and your scenario. In load balancing strategies, it doesn't really matter. Least connections, least load, round robin. You do have to take into consideration if you're using app server because you're going to need those sticky sessions. So load balancing is crucial. Session management considerations. As we begin to modernize and as we begin to transform our applications, you should always think about stateless and stateful connections. Stateless are better because we don't have to store any session data. Any PaaS can handle any requests. So if I have 4 or 5 PaaS machines, one happens to go down, it's super easy for you to pick up and hop over. And it's much better at scaling. When you go to stateful, you have sticky sessions. And when you do that, you're going to have to consider looking at some sort of shared session states if you're not using sticky sessions, something like a Redis in-memory database, or even, and I cringe at this, keeping your context data in your local database. So session management is another thing to consider when we're moving to horizontal scaling. Some of the common pitfalls, with stateful sessions, especially in databases, can cause bottlenecks. When you have too many agents in one instance, this can lead to CPU thrashing. That's the last thing we want to do. Ignoring load testing is never a great thing. If any of you know me, I always state that you should be able to load test your PaaS environment and you should be able to repeat it over and over and over again. Make small tweaks, run it again, smell for smoke, to quote Mike Jacobs. You've got to avoid configuration drift. So in order to avoid configuration drift, store all of your settings, your config files, your properties files, store all of that inside of your version control so that when you deploy, you're deploying exactly the same each time everywhere. How else to do it is to minimize database bottlenecks. And how do we do that? Well, we need to really talk about optimizing queries, which really brings me into my next topic that I want to talk about. Horizontal scaling is great, but if you've got really big queries and your queries aren't optimized, it's not going to do a whole heck of a lot, because I'm going to tell you with horizontal scaling, you need to move to a network connection database. And all of you are going to throw your hands up and say, yeah, but Cameron, I can't do that because it's too slow and I have to stay in shared memory. Well, guess what? It's probably too slow because your query structure is not optimized for network traffic. Now, there is a lot of tuning that can take place, and the DBA group can do a great job at helping you with big buffers and little buffers and network size. Not all the stuff I do, but I can talk to you a little bit about query structures and optimizations. Why does it matter? Well, I just talked about it. It retrieves records fastest, right? Fast applications are built on efficient queries, not faster hardware. You can't throw faster hardware at bad queries. So you need to really look at these things. Most performance problems in OpenEdge applications come from inefficient database access. When you have making small changes to your queries can really increase your response time. It can really reduce CPU and IO, and especially disk, and it makes things a lot more scalable. Well, that's awesome and all, but how exactly do we do that? Well, as developers, I'm going to take off my architect hat. I'm going to put on my developer hat. As a developer, I need to understand some of the basic rules. I need to go back to 4GL 101 that I took eons and eons ago in Bedford, and talking about, indexes. What indexes do we have? What indexes are built? Looking at record locking. Record locking can make a big difference and a big change in what your in how quickly queries can return data. As well, looking at query optimization, look at the compile time and runtime, look at running XREFs, and I'm going to go a little further into that. The key thing as a developer, when I'm writing a for each or I'm writing a find, I'm trying to find a record, I should be conscientious about what index it's using. And as well, I should be conscientious about how many records it's returning. The smaller the record set, the faster the return. If I'm returning 100,000 records to a screen UI, that's going to take time. And what columns? If I have a table with 300 columns in it, do I really need to return every column? I don't know. These are all things that you have to look at. One of the biggest bangs for your buck is really pulling out functions in your query. So making sure your where clauses match your indexes. Be highly selective. You want to find those things quickly. And even things like, and as I said, keeping functions out of queries. I give you a great example here. Here's a bad query, for each order no lock, where string of order custom equals the string of 100. That's a function. Every time you have to run, every single record has to run through that string function. And you say, yeah, but Cameron, but that's a built-in function and that's supposed to be fast. Yeah, but it's still an extra hop. It's easier for a good log is just to use the index that exists. I see these all the time, compounds, where you'll see where date or where year of a specific field equals the current year. You should really not be using that function inside of your query. Set it from 1/1/2025 to 12/31/2025. It's a much better practice for index fundamentals. So choosing the right index. Progress is great. It automatically selects index, but it's sometimes not always optimal, right? Use the XREF to see it. There are some cases, and I know some of you are going to jump on me about this. There are some very specific cases where you can use index. I've done this in batch programming. When you have batch programming, you're going to be loading in big files, sucking data off of, let's say, a flat file and putting it into the database. You want to use a specific index because you need to find things in a specific order. Be very, very careful with use index. It can improve performance, but overall, there are better optimization choices, and it can really damage future index creation. As soon as you say use index, you can never use a new index that's there, so the code can't be recompiled and adjusted. Avoid whole table scans. Gosh, please, for each customer, just really watch that. Reading every row in a table, if you don't have to, slows things down. Understand, folks, that there's a buffer. The database buffers records into memory, lifts it off disk, puts it into memory, sends it across the network to the client. The client reads it and then displays it to the screen. So if you're picking up every record and doing that, that's slow. That causes a lot of network thrash. So you've got slow performance and high I/O. So why would you be doing a whole table scan? Well, maybe you missed an index. You think you did a for each and you did it on a date, and lo and behold, that date isn't in an index and there's no index to choose. So Progress will pick the best one that it can, and you end up doing a whole table scan. And worst case is if you add a break by or an add a by phrase, then at runtime, it has to sort that record, that unindexed record as well, and that's going to slow things down as well. As a developer, As soon as you're done your program, you should be running a compile with an xref and searching for the word whole. Everywhere you see whole table scan, if you haven't intentionally done that, you need to address it. As well, this is another big one. Reduce the data that you retrieve. Man, if you don't need the column, don't bring it back. This is one of the greatest things that AI has helped us with, that is you can ask AI to take a look at this record scope inside of this procedure and just return the fields that I'm dealing with. As I say, if you have an order table or an order line table that has 200 or 300 columns in it, and you're really only using 4 or 5 of the columns, then why are you returning all of them across the network? It really doesn't need to be returned. Optimize. Make that data packet as small as possible and get it back. AI can really help you with this, and I've proven this. So some of the common pitfalls, they're anti-patterns. Using functions in where clauses, God, please just try and avoid those. Missing indexes. The overuse of use index. Again, it has its place. We put it in the language for a reason, but be very cautious. When you write that, ask yourself why, and please put documentation in your code as to why you used index. Nested database loops inside of database calls. You're just doing a lot of thrashing. Try and reduce the amount of data, the fastest amount of data as quick as possible. We've always touted how can finds are free, are cheaper. Because it doesn't return the database buffer back across the network. It's still a find on the database, folks. And if you're doing a for each and you've got a whole whack load of can finds in there, you're still thrashing the database. That's going to slow performance down. So really be mindful of your can finds. And then finally, large transactions. Watch those giant transactions that are coming across. Break them up if you can. Add paging if you can. I do understand that there are some situations where it's unavoidable, especially in batch processing, but in UIs, especially with modern applications, we should be looking at reducing our transaction sizes. And with that, I'm going to turn it back over to Tony. Tony, back to you.
Thanks, Cameron. I think I see a lot of potential opportunities there with AI to help in some of those efforts. So thanks again. So we've got our modern development environment set up, and we've thought through our architecture and query design. Now it's time to build, and as we build, we need to make sure that that code actually works. That's where testing comes in, and specifically the idea of shifting left, catching issues as early as possible. Steve from our professional services team, you're up.
All right. So shifting left, even if you've never heard this term before, I think you'll find that it's intuitive. Basically, all it means is that we're trying to test earlier and fail faster. All code fails. Human developers are not perfect. We all make mistakes. We all fail to consider things. There's going to be errors in your code. You're not alone. It happens to everybody. But what we can do to make this better is to move our testing and quality checks earlier in the development process, make the developers take ownership of the validation as they write the code. So to do that, we are going to use unit tests and automation, continuous integration for fast feedback. Catching defects early is when they're cheaper to fix. And AI can help accelerate that test creation and coverage. I know that a lot of people are hesitant about AI. There's a lot of questions. It's still fairly new. We've heard people say, well, I don't think I can trust AI to write my production code. Well, testing offers a perfect opportunity for AI. You can have AI write your tests for you, and that test code doesn't go to production, but it does help you have higher quality code. So when we say earlier, what do we exactly mean by earlier? How far left are we shifting here? So I would argue that it starts before you even start to write your code, because what you're going to do is you're going to come up with your acceptance criteria up front. Before you start to write the code, you're going to ask yourself, how am I going to test this? How will I know when it works? Now, some people will say, test-driven development, which is where you write the test first and then you write the code to match it. I'm not sure if I'm personally ready to go there. I find that I write code concurrently with tests. Write a method, go write the test. Write another method, go write the test. And sometimes, the development of the test helps you to develop your method. Because while testing, you're thinking, oh, well, what about this situation? So then you go back and you write some more code. So at least concurrently. But the important part is that you're validating this logic during the development and not after you've checked it in. It's too late by that point. So this basically helps you catch design issues before they become defects. And again, AI can help with this tremendously because the AI is just trained on software development and it can sort of intuitively know what to test for. So here's kind of a view of the development lifecycle. Again, on the left side is the inception of your idea and your requirements. You've got your planning and design. And then right here, pretty early up front, we're talking about writing tests. Even if you're not physically writing the test code, you're at least in your specifications coming up with the ideas of what is it that I'm going to test? How will I know that this works? How can I exercise this code against the situations that it's likely to encounter in real life with real data? And then, of course, the development, while you're coding, you're going back and forth between steps 3 and 4 here. You're writing tests, you're developing, you're writing more tests, you're developing. And of course, the modern method is more along the lines of the AI is helping you develop, and then you're asking the AI to write the tests for it. Or, you even take it a step further, like I like to do is, I've developed an AI skill for writing the tests, and I've instructed the AI as a rule, hey, when you write me code, I need you to write me a test for it as well. So it knows right up front that we are testing what we're writing. At any rate, the next step is the your build process. Hopefully, you've got a build process that every developer is running before they run the check-in. You're doing your build. You can make the testing part of your build. If you're using OpenEdge DevOps framework, that has tasks for ABL unit tests. Same thing with Ant and PCT. Make that a part of your check-in. That's a gate. If the unit tests don't pass, check-in doesn't happen. And then of course you get to step 7, which is your regular test. This is where conventionally people would start testing. You bring in your QC people and they start running through screens and so forth. And then eventually you're released to production. But what's important to point out is that the cost increases as you go from left to right here. The cost of bugs is higher on the right because you have to go back through more steps. You've got to perform all those steps again once you fix it. So catching it earlier is better. I think we all kind of instinctively know that. We've all been there. It's just sometimes hard to think about it when you are so stacked up with work. We all want to get things out the door, but it's the old adage that if you don't have time to do it right, you're not going to have time to do it over. So again, just talking about the cost of this, in our world, time is money, and I don't know any developer who doesn't have, a stacked up workload. We all have bugs to fix and new feature requests and all that stuff. We need to save time. And by taking the time to slow down to write the tests, we're actually slowing down to get faster. So, think about yourself when you're in the zone as a developer. You have a piece of code open, you're intimately familiar with it, it's right in front of you, you're working on it at this moment. What better time is there to test it than right now? So, you write the code, you write the test, you run them locally. You see failures right off the bat because ideally, you've had the AI to write you some unit tests that don't just do what developers like to do, which is to test the sunny path. You know how we are. We like to test, I need it to do A, B, and C. Does it do A, B, and C? Yes, it does. Good, problem solved, we're done. But you got to think about, sometimes the specification is that it will not do X, it will not do Y, and it will not do Z. So those are things that you have to test. And I have found that AI is pretty good about testing failure modes, testing, sending it garbage data. It is pretty good at QC. So the idea is to fix it here on the left before it becomes expensive, because once you check it in, think about your process. Next thing you know, you're going to do a pull request. Okay, so now somebody's got to go approve that pull request. They've got to review that code. They're looking at the code. They may or may not catch the defect. It goes to QA. QA may or may not catch it. But if they do, you've just wasted their time. Now it's got to come back to you. So, this whole defect cycle and the rework cycle, meanwhile, this developer has already started on other tasks. You're already doing other things. It's not fresh on your mind anymore. And we know that task switching kills productivity. So all this is just a lot of words to say what I think we all intuitively know. We've got to get better about catching things up front. So let's talk about the design of this. I mean, a lot of people write code that is just untestable. What I mean by that is, think about a case where, let's say you've written code that is going to import a JSON file and create an order in the database. So you've got a 1,000 line .p file that does everything from parsing the JSON to validations of individual data points and so forth. How many functional things do you think that 1,000 line .p has in it? How many orders and how many different ways would you have to create an order file to test every single line of that code? This is why I say that it's important to design for unit testing up front. Try to develop small and focused methods, procedures, and functions. Have a given method or function have one responsibility: defined inputs, define clear outputs. If you can separate your business logic from database transactions, that makes it easier to test, because now you're not worried about contaminating your database or having to worry about specific data being in place in order for a test to be valid. So it goes back to what we've been telling you for years, which is to avoid mixing up your UI, your data access, and your business logic, your rules. And lastly, trying to minimize those hidden dependencies. So what are hidden dependencies? These are basically just like, say, shared variables, or the state of something being in the database. Ideally, your function or your method takes certain things as input and it provides outputs in a very deterministic way that doesn't rely on, the moon being in a certain phase, if that makes sense. So to make your code testable, you can isolate your database access behind interfaces. Try to have a layer for your database access if you can. Design your code so that various dependencies can be mocked. Maybe a good example is in the web world. If you're doing web handlers, if you can mock that web request, now you're not having to send the request over the web. You're just passing in a web request object. So that's one thing you can do. Have your methods return values, or output values, or data sets that are easy to assert against. Another thing is just, keeping the side effects predictable. And if it requires a full database to test, then maybe you're a little too tightly coupled. So we have a tool, and surprisingly few of our customers use it from what I've seen, but it comes with Progress. It's free, it's there, and you can use it. If you have Developer Studio for OpenEdge, the tooling comes right in that. But there's also a free extension for VS Code. So it's right there and available to use. In ABL unit, we have what are called test suites. And basically, this is just an empty class. You can see here, there's a class statement and an end class on the next line. And it's just a bunch of annotations to say that this is a test suite. And these are some classes that I want to test. So for example, in my build script, I may have a test task that runs this test suite. And this test suite is going to run through and test all my code in my project as a gating factor before I release. So let's look at what some of those tests would look like. Basically, it's just a class that has public void methods in it. And each of the methods that constitutes a test has the @test annotation in it. That's how it knows that this is a test for it to run. Your test class can have all kinds of methods in it, helper methods, methods to set things up for testing and so forth. But only the ones that are marked with @test will actually be run when you run your test. And then those can call other methods as needed. So you can have multiple tests in a test class. I like to have one test class per class that I'm actually testing. And then, you've got multiple tests to test different methods or different things, different aspects of your class. Sometimes I have tests that test the instantiation of the class. And then each test, of course, can have multiple assertions. So this is an example here of I have an ABL class that converts various JavaScript date formats into OpenEdge ABL dates and date times and things like that. So, it's a nice utility class. It's separated out. I can use it from wherever. And so I wanted to make sure that it's always accurate. So I've got this little test class that goes through and throws everything it can at it. And the examples you see on the screen are all Sunnypath examples, but it actually does throw a lot of dirty dates and things like that to test how it handles errors. So you've always got to put in testing for your edge cases, corner cases, and error conditions. In Developer Studio, you have an ABL unit tab down at the bottom of your screen, and you've got an icon up at the top. You can just run your ABL unit test, and you'll see the results in the panel down below. It shows basically whether the test class itself passed, and then all of the tests within the class. It even shows how long they took to execute. So that's one additional measure that you can see that kind of shows you about your code quality and the speed of your code. And we also have this in VS Code. I like to use it in VS Code. It's a free extension you can get. Here's an example of the same class being tested there. And you could see the results of it. All the green check marks mean that everything is passing. And of course, that center panel there down at the bottom would kind of display what went wrong. If one of these failed, you'd be able to click it and get kind of a description of the error so that you could go fix it. And I will say also that, the AI that comes with VS Code, if you're using GitHub Copilot, it is very good at troubleshooting. It knows the relationship between ABL unit and the code that it's testing. Quite often you can just be lazy and tell it, hey, this is failing, go troubleshoot, and you get your answer. I want to point out one other nifty aspect of this particular extension is that it does show you your code coverage. And by code coverage, what I mean is the percentage of your source code that is actually being exercised by your tests. So you can see over here in the left panel, I'm testing the dateUtils class with this test method. So it shows a 97% indicator. And you can see in the code window, some of my lines are marked with a green highlighting. So that just means that those are executable lines of the code, and those lines have run as part of the test. So you should see a high number like 97%. It's not really always possible to get to 100% because there's certain error conditions you'll just never be able to achieve in a test scenario, but generally having those numbers as high as you can get them, running the test with coverage, making sure that number is high and that you have good coverage on all of your classes is a good way to know that you're testing everything. So this gives me assurance that if I go in and I need to make some tweaks, let's say I need to go add a method or change the way I do something in this class, before I check it in, basically the process is such that I can't even build it until the test pass. So that's how we help ensure code quality. So I'll hand it back over to you.
All right, so thanks, Steve, and want to give a shout out to Ken Herring, who wrote the Visual Code extension for the ABL unit test runner. He's a member of our OpenEdge community for a long time and wrote that for the community. So anyone can find that out on the VS Code extensions. I think ABL unit test adoption becomes much easier with AI assisting in creating and maintaining these tests. So we've got tests running, but testing alone doesn't tell you whether the code itself is clean, secure, and maintainable. And this is especially important now that AI is generating more and more of your code base. Is that AI generated code actually good quality? Is it secure? Steve, you're going to stick around for this one, and Roland is rejoining you. Let's look at a few of the many options available for quality gates every team should have in place.
Yeah, thank you, Steve. So that's a nice bridge indeed, talking about the code quality. So I'd like to add a couple of topics to this, to the code quality overall. So first of all, a couple of years ago, Progress, we partnered with a separate company, SIG, the Software Improvement Group, especially on this very topic, so on code quality. As the name already says, Software Improvement Group, so their focus is not building software just like most of you guys do. They focus on the quality of software in general, not specific for ABL. They support something like 300 plus languages, but one of those is also ABL. What the platform does is it gives you a very detailed overview of the quality of your code based on the ISO 25410 standard, your architecture, so it looks not just at the specific lines of code, but gives you an overall picture of your architecture, dependencies, if your functional breakdown is correctly implemented into your modules, the flow of your application code over time, so who changed what, is the knowledge of the source code divided over your developers based on your Git history and what have you. Last but not least, the S in QSM stands for security. So also implementing the OWASP top 10 specifically for ABL coding rules. Because if you AI generates code, of course you, as Steve just explained, of course you have all your tests in place, but you also want your code to guarantee that your code will be of good code quality, but also that it will be secure. The QSM platform, as said, there are two different flavors. First of all, the cloud platform itself. So periodically, you can upload your code into the platform, and that could be probably that's part of the pipeline. So based on your CI/CD, could be after every commit, but ideally after every sprint, your code gets uploaded, and you can go to the dashboard and can see exactly what happened in the last couple of weeks. Are there any features added to your code that have a negative impact on your code quality? Are the security rules broken? What have you? But the second thing to it, and that's what SIG added lately, is the ability to have the same kind of functionality using the QSM MCP server. So directly from within your IDE, the platform is being addressed, and it will give feedback on the quality of the code at hand. So why did we add it to it? Well, the code that's being generated by AI gets larger and larger over time. So that means that in the beginning, you will verify everything that's being generated because it's all new, and you just want to be on top of it. But over time, as you've just seen, I mean, if the tests work, you get the results you expected. Over time, you're not checking the code itself anymore. Your code reviews are, well, it works, so why should we check all those hundreds of thousands of lines of code that are being generated? But there's a big danger in there, and because AI is based on, of course, the rules and the skills that you define, and we'll go into a little bit more detail after this one. But it's also based on what it sees in your code base, because that's what it uses as a basis for generating code. That's the context. And that's a very good thing, because you want the code to be generated just unlike the code you already have. You know, it should be following the same design patterns. It should use the same libraries, persistent procedures, what have you. But it also means that if your code is not perfect code, it will generate in the same way as it was in your code base. And especially if you're not reviewing, if you're not checking every line of code that's being generated, that may have quite a negative impact on the quality of your code base. So that's why we've added this feature, so that continuously, directly from within your development environment, the AI will reach out to that MCP server and say, okay, what's the quality of this code? Is this good enough? Is this according to the references that I said? So you define your own quality gates. It should be of a certain quality level, and that will be continuously checked using that MCP server. And it will also give the feedback that you as a developer can evaluate, and in the end, you're still the one in charge. So look in the small picture here. Once the AI generates code, or maybe even looking at existing code that you're working on, the IDE, the AI in there will reach out to the QSM MCP server, and that will give it feedback on code quality, security, and maybe even on architectural aspects if they're being touched upon. That will be returned in a JSON format with severity levels. And of course, we're not doing gold plating here. You know, the code needs to be good enough. So you define what is the quality of the code, what should be the quality of the code, and the AI will react on it and will say, okay, this is below my quality gate, so I will refactor the code. Again, it will be sent back to the QSM MCP server. So then it will say, okay, I've changed the code according to your rules. Is it now good enough? If not, it can make an extra change in there. In the end, as I said, the developer is still in charge. That's the one who has to approve or reject the changes that have been made by the AI. And it would say, well, okay, but it's AI, you know, it's smart, it says it's intelligent. So why should I bother? And I think a very good example is what happened 2 months ago at Anthropic. They asked the AI to generate a complete new web browser. They set up an environment with a swarm of 50 agents, and within 3 days, they generated 1.2 million lines of code, and it resulted indeed in a working browser. So that's all good. But the quality of the code was also assessed by SIG. Their assessment, their qualification goes from 0.5 to 5.5 stars. Nobody gets 5.5 stars. But they assessed this code and they got a 0.6 star rating, which is really, really low, which is basically unmaintainable code. And it was brand new code generated by AI. So just as an indication, yes, you need to keep an eye on it. Together with what I've already mentioned before, together with the rules that you define in your own application. So together with the rules that you already have, you can define, okay, this always needs to be true. These are being decided by the model, or they can even be very specific per type of code, like for having .p files, .cls files, includes, or maybe other languages that are also part of your code base. So you can add those specific kind of rules that the AI should follow in combination with the MCP server. So yeah, wrapping it all up together. So dividing those rules into skills, it will save you money because you pay per token. So the less tokens, the less money that you need to spend on your team. And it will also make the outcomes much more predictable because this will help the AI to generate good quality code. Thank you for listening, and back to Tony again.
Thanks, Roland. I know Cable is another available product through Riverside Software that can assist ABL developers. So at this point in the life cycle, we've designed our architecture, written modern code, tested it, and scanned it for quality and security. The next question is, how do you get it deployed reliably and repeatably? That's the DevOps piece. And for this, we're going to turn to Edsel, drawing from his engineering background and his Project Garage work. He has a lightning talk on exactly that. Edsel?
Thank you, Tony. All right, so let's talk about DevOps concepts. So we have first CI/CD. CI/CD is the automated workflow that guides the source code from the source code repository through build, test, and release. Right? So the phases that you have in a CI/CD pipeline. The idea being is that this is done with automation so that each phase can be improved continuously. You have the concept of configuration as code. So the configuration of the machines or containers that you're using to build, test, and run the application, they are done through a definition that is stored as a file, as code into source control. Then you have also infrastructure as code. Infrastructure as code is that the instructions on how to create the virtual machines or the containers, again, to build, test, and run the applications is expressed into a file and then saved as code into a source control system. Generally, you would have different source control systems for the actual source code of the application and the one that is used for configuration and infrastructure. Then you have also containers. Containers is a lightweight virtual expression of the processes that are used for running the application, and each much lighter than virtual machines. So you're not actually running an operating system, you're running the application plus the libraries that it needs to actually run. So let's take a look now at the benefits of CI/CD. Well, the main benefit, I think, is repeatable, consistent results. So you're using automation with a pipeline that goes from the source code all the way to releasing the software, perhaps to a repository manager, and then deploying the application. Because you are building, and the idea is that actually you would build a deployment package or a container image, and then use that as part of your testing process, all the unit testing, end-to-end testing, integration testing, security scanning. And then if that image, the test pass, then you move it to the next phase. It is promoted from the test environment to the staging environment, and from the staging environment to production. And because you're using an image and you're using automated processes to create the environment, you get repeatable, consistent results. And that way, what you have in production should work just the same, that's the expectation, as it works when you run it in your test environment. You have then business agility and stability. Basically, you have a way to now improve your software and ensure that the software is stable because it is built, test continuously. So the DevOps becomes a continuous journey, something that you now have the structure, the framework for building your application and testing and deploying. And then you can look at that process and improve it continuously. And those improvements certainly can be different type of modernization to your application, modernizing your processes. Perhaps now maybe you're using containers, maybe you're now using new technology into the way that you work and you build your application. Perhaps you're using AI for some of these processes, and because you are using a CI/CD pipeline that is already in place, you have basically the assurance that allows you to build your application in a way that you know that is safe. Here we have the continuous development life cycle. This is another way to see the CI/CD process, right? We have plan, the gathering of the requirements, then we have code. The source code is written and is checked into source control, then is built, then is tested, then is released, deploy, operate, the actual running of the application in production, and then you can monitor the application. This is like perhaps you're using OpenTelemetry to monitor your application. And that is the process, basically something that happens in a continuous basis. The main phases that we talk about, of course, are continuous integration, right? You check in the source code, and then it triggers build and sanity tests and code scans. There is a continuous validation, right, which is also part of the entire process. And in the continuous validation, you are now testing the application at different functional level, maybe acceptance, user acceptance tests. You're running perhaps a performance test as well, security scanning, and then you have the continuous delivery, right? So now you have built artifacts that are potentially shippable and delivered at the end of the pipeline. Now, this is continuous delivery, but it is also continuous deployment. The difference between continuous delivery and continuous deployment is that continuous delivery takes the build artifacts, installation packages perhaps, or container images to the end of the pipeline, perhaps a repository manager that now customers can use to download the software and install it. With continued deployment, what happens is that the installation, the deployment of the applications is done automatically from end to end. Okay, so how to get started with CI/CD? Well, first, build a basic automated pipeline, then iterate, right? So build the most basic that you can from the source code all the way to, let's say, delivery, and then automate all the components that you can, right? So now you have something that works and you can iterate on that. So like, for example, you can automate the creation of the infrastructure, right? Then you use the principle of infrastructure as code. And you're working, of course, on the basis of testing the application because quality is key. So you also add a good number of unit tests and a good number of integration tests in your application. And then you can focus on the areas of the pipeline that needs improvement based on your organization requirements, right? So you can look at each of the components, each of those phases. A maturity model, basically a model that is used for understanding the concepts. You can use it for CI/CD. There is one in particular that I looked at a while back and I liked. This is the one. This one takes you from a very high level perspective, not just from the technology perspective, but you can see there is like a big challenge. Now you build a baseline, you work now at an intermediate level, you have advanced level. And there are many other maturity models out there that you can use. All right, so continues on how to get started. Well, use best practices. And one of them, right, of course, is to automate the build and the infrastructure as code. Another key element is to let every developer, to commit to the mainline every day. What does this mean? Well, it means that the source code is built and tested often, and is done in a way that you want to have code that is basically correct, right? So you check-ins that don't have a valid update wouldn't be checked in, right? But they could be small and get into the source code and then allow for the continuous process. You can isolate and secure your CI/CD environment depending on your needs, and building once and promote the result through the pipeline, it's also very important, right? So this means is either build and the deployment artifacts, right? The deployment packages for your application, or basically container images. And then as you test, you can promote them to the next stage of the process, of the CI/CD process. And because you're using the same image, the expectation, again, is that you will get the same results through the process. The opposite to that, just to contrast, is that in all times, perhaps there was a build and, the software now runs, right? But now when it goes to the staging environment or goes to the production environment, the software is somewhat different, right? So that's the anti-pattern. The pattern that we want is the build once and promote the results to the pipeline. Okay, so some CI/CD components. So the main components, right? So we have the source control system, for example, GitHub or GitLab, to a cloud-based Git environment. You have a CI server, a continuous integration server. In GitHub, this is called GitHub Actions. In GitLab, it is called GitLab CI/CD, I believe. And then you have a CI agent, which is a runner program that is installed on the virtual machines and allow for the programs for the CI server to tell the machine to build or test a certain software. And this looks slightly different when using containers. You will also have a repository manager. Like, for example, for GitHub, you have the package registry, and there are other repository managers out there. There is the infrastructure managers, such as CloudFormation and Terraform, and also you have the configuration managers, so like Ansible or Chef, right? Progress Chef. And there is a nice DevOps periodic table out there. You can find it on the web that gives you good overview of all the DevOps tools that are out there. All right, so let's take a look at how this process would work, right? Considering just the main build, test, staging, and production phases. So we have the developer working, let's say, at the desk, right? And then they use development tools, link tools, unit testing tools, and a source control client to work with the software, write the software, check in the software into source control, and then it goes into the source control, and that change triggers the CI server to take from the source control into the build system and build the application. The artifacts from that build then are stored into a repository manager. Then comes the next phase, the test phase, where you could use infrastructure and configuration managers to create a test environment. And remember that this idea is that you would use infrastructure as code and configuration as code. So the definition for the test environment is expressed as code. And this configuration for an infrastructure would also be used for staging and production. And then the tests are run, unit tests are run again. You have other tests, integration tests, end-to-end testing, right? You have code scanning, security, performance scanning as well. And then if all those tests pass, then that same image, being a zip file or other type of deployment package or a container image, is promoted to the next stage, to the staging stage. And then there is another repository manager. Why? Well, because the test environment maybe is running on premise, and you have that repository manager. And the staging environment is running in the cloud, and you have a repository manager that is available in the cloud to the customer to download and install the software from. Or if you're doing CI/CD as in continuous deployment, then that repository manager would be used to do the automatic installation of the software as well on the end environment. All right. And then you would create a test environment that could be a host environment like virtual machine, or perhaps would be Kubernetes. Now, here's an interesting concept that you would probably use, and there's a deployment strategy known as blue-green deployment. There are other deployment strategies, but in particular, blue-green deployment, you have two environments that switch roles as you test the software. So then you have one environment, let's say the blue environment, and that is the one that is running on the staging. And then if all the tests pass, then what happens is that it switches role with the previously or currently running production environment, right? The green, or vice versa, right? And then what you do is that the case is that the machines on the staging environment, that they have proven that the software works, that is with the quality that is accepted by the users, then now takes the role of production, and the previous machine takes the role of staging, and then it switches role with the deployment. If you're using Kubernetes or in particular, right, another approach, then you could use what is called rolling updates. And I hope that this CI/CD concept is something that you can use and apply and use it to modernize your application. Thank you.
Thanks, Edsel. That continuous deployment cycle really ties the build and deploy story together. So now that your application is architected, built, tested, scanned, and deployed into production, the final question is, how do you keep it healthy? How do you spot problems before your users do? That brings us to our final topic, memory management and the OpenEdge profiler. Cameron and Edsel are teaming up for this one.
Great. Thanks again, Tony. Okay.
Thanks, Tony.
All right, so let me take the first few slides here, the OpenEdge memory profiler. So for the OpenEdge memory profiler, we have built a tool that you can use to analyze the memory usage. This tool is now available in OpenEdge 12.8, also available in OpenEdge 13. There are two main components for the tool. You can use the profiler on the ABL client and PASO-E, and you can also use the OpenEdge memory profiler that has a web UI and a backend component where you can use it to analyze the memory usage, to manage recordings, to visualize the data for the recording, see the snapshot summaries, and also compare snapshots. So some of the key benefits, well, it helps you to identify the excessive memory consumption. It helps you to detect memory leaks. A customer a while back mentioned that when they had a memory leak issue, that they have memory leaks issue often, but when they had one, they had to debug it, of course, and they would spend weeks to debug the application and figure out why the memory leaks. So the OpenEdge memory profiler helps you with that debugging, right? So now you have a way to do that in a much, much efficient manner. And this improves productivity and also gives you a way to see how objects are used in your application and have a much better understanding of your application. All right, here's how the OpenEdge Memory Profiler, the web UI, looks like. And to get started is actually very easy, right? So you can install it on Linux, you can install it on Windows. 3 easy steps. You run on Linux Pro ENV, you extract the installation utility from the distribution package, and then use that installation utility to install OEMP, just a single command. If you're doing this on Windows, is basically the same, right? So you do Pro ENV so that you can run the installation utility. You extract the utility, perhaps with PowerShell or any other way that you have to extract files from a zip file, and then you can run the OMP utility install. And that gets you the program installed. And now to you, Cameron.
Thanks, Ed. So yeah, that's great. So now we have this memory profiler installed, and you got a little quick sneak peek of what it looks like. What does this actually do for us, and how can we actually use it? Well, we have to make and collect OEMP files, and OEMP files can be collected two ways. The first one is through your ABL client. And what we do is we capture a file, and in the file, it contains snapshots. And we have automatic snapshots that take place throughout your entire program. And so there is on the command line, there is a dash profile memory, and then you pass in a memory profiler config. We're not going to go into the details of the memory profiler config file, but you can look it up, but it is in our documentation. And basically what this does is it tells it how often to make a collection and the certain kind of things to collect. And then you tell it the program you're going to want to run. While that program is executing, the memory profiler will, based on the config files, collect those OEMP files. That's great if you're running on a character or a GUI client, but what if you're running in PaaS? Well, there's a stanza in the agent server that allows you to turn it on. So where the agent startup parameter takes place, most of us are familiar with this. Same idea, you give it a dash profile memory, and the location to the memory profiler config, and it will turn on profiling as well. The config files can be the same. So in a CI/CD and in a repeatable testable environment, you can use the same config file. So that's how you build these OEMP files. There is an import. I believe Edsel's going to talk about that a little further down, but we have a folder that automatically gets picked up. So what we do is we take and we start the memory profiler, and you can see here we have a utility both on Linux and Windows, an OEMP SH and an OEMP BAT, and we give it a simple command, start. This will start the OEMP database and the PaaS instance and allow you to have access to it. In the working directory of OEMP, there is an import directory. You'll see it clear as day. It says /import. That's where you want to drag and drop your .oemp files that you just generated in the previous slide. So you take and generate, and then you put them into that machine. Does the memory profiler need to run on the same machine as your PaaS machine? It doesn't have to. It can run on its entirely separate virtual machine. It can run anywhere. It can run on a dev machine. Anywhere that there is a license for workgroup database and PaaS, it can run. To visualize the recordings, this is where the magic takes place. We put everything on 8880 and 8883 for those of you that are HTTP conscientious. So we're going to give you in the OEMP files, we're going to give you a bunch of automatic snapshots, and those are great. You know, they give you a snapshot, you know, in an increment that you want, and they're taken and you can look at it. But what if you want to really hone in on what you feel could be a memory leak? So we gave you a way of taking a snapshot. One caveat is when you write your own snapshots, you can't start it with underscore. So please, please, please don't start it with underscore or hash or any of those. Just give it a name, okay? So what you do is on line number 1, you bring in the progress.profiler.memory profiler. Let's say this is your suspicious code that you want to take a look at. You'd simply come in here and you could add your memory profiler, and you're going to take your snapshot. So you would memory profile, take snapshot, give it a name, you could call it whatever you want, then run the procedure or method or code in question. and then take your post snapshot. And what that does is the snapshot itself takes a look at the objects in memory before the run, and the post takes a look at the memory objects after. And it tells you, it can show you, hopefully, that your line is clean from snapshot to snapshot, that there's no increase in memory. This is the basics for how to do this. We go into a lot more depth in some of our workshops. You should come to some of our PUG workshops and take a look at these. We'll talk more about these, but this is the basics on how you do automatic snapshots and do programmatic snapshots. I'll turn it back over to Edsel, and he's going to talk a lot more about the screen and the UI. Back to you, Edsel.
Great, thank you, Cameron. So here we are now into the OpenEdge Memory Profiler Web UI, right? So we have additional recordings that have been imported by copying to the import directory. And now we can take a look at one of the recordings. So here we have one of the recordings. We have mostly a horizontal line, and then it decreases at the end. So this one shows the healthy execution of a program. There is no increase of the memory usage. It mostly stays flat in this particular example. However, notice that we are actually only taking here 3 snapshots, right? Now, we still have this pre-cleanup snapshot is one of them, right? And it's showing that at the end of the program execution, right, before the exit, the application memory, the platform memory, they are relatively low, right? There's only one object there and one widget pool and no 10 tables objects after the end of the program, right? That's the pre-cleanup snapshot, which is shown by default when you access this. So here's another example. So now we have used the pause. Sorry, no, this one is done using the take snapshot, and now there are 2003 snapshots in total. The program execution is the same, right? The memory usage stays flat. What the difference is now we have more data points in the graph that we can use to analyze and look at each of the snapshots if required. Now here we have the pre-cleanup snapshot. This one is from basically the same program. Now the difference is that we have more snapshots and the memory usage remains the same. The difference now we actually have here, we can see that the progress profiler, memory profiler was used. All right, so here we have another example. In this one, well, the memory usage has continuously increased. This one, of course, is exhibit an increase of memory consumption, right? This is a memory leak. At times, you may have other charts, right, that are not necessarily just a straight line, right, that they have ups and downs, but you could be able to tell if they are going in an increasing fashion. So this one we could see that, but we have only few snapshots. Well, but notice on the pre-cleanup snapshot, we can see that the application memory usage was of 24.5 megabytes. Right, so this is certainly using a lot of memory after the program has finished. There was also an increase of the platform memory, and we can see that there are 1,001 objects also there. Right, so this certainly is exhibiting a memory leak. Well, now let's look at another version of this program, another run, but with the snapshots, right? So we have the 2003 snapshots, right? More data points that we can use to analyze the application. Again, the pre-cleanup snapshot shows the increase in the application memory, right? The platform memory and objects as well. All right, here's what you generally would do. Then you have the chart, right, in the OpenEdge Memory Profiler, the web UI. You can click on that line on the chart and then be able to see the snapshots that corresponds to the 1 second interval for that. So in this particular case, there are only 2 snapshots. You may have more, right? But these 2 snapshots, and actually you can see the tag there for this one, is the pre-snapshot, right? So those snapshot before and after the application run, and you would be able to see them, and then you can compare them, right? So, and here the comparison, right? We are only comparing these 2, right? For one particular run, you can take a snapshot, previous and after. Larger code is up to you to decide, right? And in here we can see that there was 1 more object created between the 2 snapshots, and there was an increase of memory usage by an ABL type, right? In this case, and you can drill down through these dialogues, and you can find that this is the query that is not being deleted, right? And from let's say a memory management perspective, right? What you want to do, right, if you're working with ABL, is if you create the object, you want to delete it, right? That ensures that it's deleted, right? There are some objects that are deleted or are garbage collected automatically, right? But if you create an object, like specifically like with handle-based objects, then you want to do the delete operation yourself. An alternative also is that you can use widget pools to help you manage the disposal of those objects. And so here, in brief, it is the OpenEdge Memory Profiler tool. And I hope that if you have the need to analyze the memory usage of your application, you can use it and have much better applications for you today. And with this, thank you, and back to you.
Thanks, Cameron and Edsel. And that wraps up our journey through the full development lifecycle, from designing modern code all the way to production monitoring. Before we jump into questions, I want to flag a couple of resources for you. If any of what you saw today sparked your interest, especially around object-oriented programming, there are courses available, including Introduction to Object-Oriented Programming, that we'd recommend as a great next step. We'd also follow up after the webinar with links to resources, recordings, and ways to engage with our teams. If you're interested in hands-on modernization help, our professional services team can help with consulting and strategy, and our A team, through the Project Garage program, offers focused, mentored development sprints where our experts work alongside your team to deliver real results in days, not months. Okay, that's it for our presentation today. Susan, do we have time for questions?
Thanks, Tony. We actually ran late today, so what we're going to be doing is capturing all the questions that were asked during the session and get back to everybody after. So we appreciate all the time that you've taken today. Please join us on Community or on a Discord server, and we will get back to you individually. So from all of us at Progress to all of you, have a great day.